coupling reactions. Joining, we can say simply. In this case, diazo group remains in the product. Diazo group stays in the product. Whereas in the previous 5 or 6 reactions, the nitrogen is going out. Removal of nitrogen is happening. But in these sort of reactions, diazo group stays in the product. So let's see what are the reactions. Those reactions we can call it as coupling reactions, or else we can say this one as formation of dies. Formation of dies. So 3 sort of dyes we are going to study now. Coloring compounds, we can say dyes means gives color. That's it. So 3 dyes compounds we are going to study now. Phenol orange dye. So in the name itself, it is denoting the color. Phenol orange dye. And second one is aniline yellow dye. Third one is naphthol red dye. So let's see what are these dyes and what is the color and how the diazo group stays in the product. Let's see that one. So first of all, let's take phenol orange. So in the name itself, it is denoting the one of the reagent is phenol itself. So let's take phenol OH. Now, what is our another compound? Diazo compound. This is our diazo compound. So to show the coupling reaction clearly, I just tilted the diazo product. So this is one is phenol. So what happens here? Cl goes out. This pi bond going to break to satisfy the positive charge on nitrogen. So what happens? In this phenol, this carbon, one hydrogen is present. This hydrogen goes out and this carbon forms a bond with this nitrogen. This carbon forms a bond with this nitrogen. This is nothing but coupling. So this happens in the presence of base. So that OH minus will be present. Came out very easily. So we are using OH minus. So what happens here? Same phenol group remains intact. And this one N, double bond N. Here no Cl minus. This N is attached to aryl group. So this is going to happen. This is phenol orange. This is phenol orange dye. So where the coupling or where the joint happened in between carbon and nitrogen. So we can call it as CN coupling. Carbon and nitrogen coupling. So see the product. Diazo group remains here. It doesn't goes off. It stays in the product itself. So this is the coupling reaction, one of the coupling reaction. So let's see the mechanism. I'll explain one of the mechanism. So for remaining both mechanism is same as that of this one. So what we are going to take here, phenol and our OH minus. This acidic hydrogen goes here by breaking the bond and giving the electrons to the oxygen. Finally, forming such sort of ion. This is phenoxide ion. So now I got a doubt. Here O minus is there. Why can't O go and do coupling with nitrogen? Why only carbon is interested to do coupling with nitrogen, but not this O, oxygen? Why not this phenoxide ion? Because carbon is having less electronegativity when compared to oxygen. That one we know very well. So among this oxygen and carbon gives out electrons very easily. Can easily gives out its electrons and forms coupling to the nitrogen. So that is the reason coupling happen in between carbon and nitrogen, but not in between oxygen and nitrogen. So same thing here also, resonance happens. This electrons goes here. Rotation of pi electrons going to happen here. So same resonance. So I'm writing at a time here. O, here double bond O. So at this position, negative charge. So now this carbon here, coupling is going to happen with what? Diazonium salt. So to satisfy the positive charge, this bond is going to break, and this one approaches this nitrogen, resulting in double bond N. Positive charge on nitrogen obviously vanishes and the Cl goes into the solution. Due to the force of attraction only, they both paired up, N plus and Cl minus. So due to this rearrangement, again this bond is going to break and the Cl minus goes into solution. So, but here the aromaticity is not at all happened. So what is the next point? Hydrogen has to lose. Hydrogen should lose to retain the aromaticity. So how it's going to lose? N double bond N pH. Here hydrogen is there. So sorry, this one. Sorry, by mistake. Now aromaticity is not there here. So to retain the aromaticity, hydrogen should lose its electrons. So how it's happening here? This electrons comes here, this one goes here, and this one again resonance. Now here the Cl minus will come. As that one is in the solution, it takes out the hydrogen as HCl, and now our aromaticity, we got the aromaticity in double bond N pH. Then again the hydrogen will come and held this O minus. OH, N double bond, N, PH. This is our phenol orange dye. Let's quickly look at aniline yellow dye and naphthol red dye. Mechanism will be same for the remaining two also.